Let's start exercise C of chapter 2nd, right? Now topic which we are going to discuss is conservation of energy. Conservation of energy. Now what is the principle of conservation of energy? Lot of time I told you that energy neither be created nor be destroyed. It only transfer from one state to another state. Okay? Energy neither be created nor be destroyed. It only transfer from one form to another form. Right? This is the principal statement of the energy conservation. Right? Conservation of energy. It means what? Sum of all energy in the universe, sum of all energy, all form of energy, okay, in the universe is constant. Sum of all energies, different forms of energy in the universe. And if we do the sum of all these energies, then we find the constant energy. There is no loss of energy, right? Energy neither be created nor be destroyed. उसको हम नए से तैयार भी नहीं कर सकते, या तो उसको हम क्या कर सकते हैं, ना डिस्ट्रॉय कर सकते हैं. ओनली ट्रांसफर फ्रॉम वन स्टेट टू अनदर स्टेट. मीन्स केमिकल है तो हम मैकेनिकल में ले सकते हैं, मैकेनिकल है तो इलेक्ट्रिकल में ले सकते हैं. अलग अलग फॉर्म में हम उसको चेंज कर सकते हैं, बट वी कांट form it or create it, and second thing we cannot destroy it, right? So this is the energy conservation rule. Now if the potential energy is going to convert into kinetic energy only, then we can say that the total energy remain constant with the sum of potential energy and kinetic energy. Okay, in your book verification is given, okay, but that verification will not be asked, but applied question on that topic may be asked. So assume that a body is falling from the height, say h, okay, body is falling from the height h, initial position of the body is say a, okay, where its initial velocity is 0. Right? Now it starts falling down and reaches to the position say B. Okay? And here it covers a distance x. Okay? It means it displaces by a distance say x. Now at the position B, what will be its height from the ground, or position C, which is at the ground? So we find here, this is h minus x. Total is x, h, and this is x. H minus x. Right? Now we are going to calculate over here the energy possessed by the body at different three positions A, B, C, and whether the total energy possessed by this body is same or constant or not. Okay, that we are going to study. Now let's see at the first position. Position A. Position A, as I told you, initial velocity is 0. Okay, kinetic energy at the height which is at a constant, so is 0. Okay, and due to the height potential energy, a body of a mass having a mass m which is at a height h experiences a gravity, so mgh. Right? So B is what? mgh at this place. Okay, kinetic energy is 0. So if I talk about the mechanical energy, total mechanical energy, which is nothing but kinetic energy plus potential energy. Kinetic energy is 0, potential energy is mgh. Here we find it is mgh. So mechanical energy at position A is mgh. Now let's see at the position B. Position B. Now this body at a position A starts falling down. So say that it acquires a velocity v1 over here. So initial velocity become v1. Okay, initial velocity become what? v1. Means, sorry, initial velocity is 0 and the velocity become v1. It started to fall down, right? Second thing, it displaces by a distance x by position B, reaches to the position B. B position को आएगा तब तक कि वो x displacement कर चुका होगा. And at that time, it acquires a acceleration due to gravity, which is nothing but say g. Acceleration due to gravity कितना होगा? G होगा. Now we have an equation that v square is equal to u square plus twice as. Now what is v square? That is v1 square is equal to u square means 0, twice a means g, s means x. So I got v1 square is equal to 2gx, right? Now what is formula for kinetic energy? Kinetic energy is nothing but half of mv square. So I get here half multiply m multiply 2gx. So what I get? 2 to get cancel, I got mgx as a kinetic energy. Right? We have to calculate total energy, but here kinetic energy is calculated as mgx. Now at this position, body is above the ground, so it possesses potential energy also, right? Above the ground at position B, so it possesses potential energy also, and that potential energy is nothing but mg h means what? Height is what? H minus x, right? H minus x. So what will be the total energy? That is kinetic energy plus potential energy. Kinetic energy is mgx plus mg h minus x is the potential energy over here. So we get mgx plus mgh minus mgx. So mgx get cancelled and we get the answer as a total energy again mgh. Means at this position A we find total energy is equal to what? Mgh. At the position B we found total energy as what? Mgh again, right? Now let's see at the position C. Means at the final position what will be the velocity? Okay, total energy. Now here in this case, let's say at position C. At position C. Okay, let's say at the position C, u initial velocity which is 0, right? U which is the initial velocity 0. Here the displacement of the body while reaches to the C is h. h displace हो जाएगा, h height से आ रहा है तो h displacement बताएगा, and acceleration is nothing but due to gravity. So g, acceleration due to gravity is what? G. Okay. Now here we have an equation v square is equal to u square plus twice as. Okay. Same equation we will use. Okay. So that is equal to v square is equal to 0 plus twice as. And what is the value of as? As is a means g, s means h. So I say v square is equal to 2gs. Gh. 2gh. Right? V square is equal to 2gh. Again, kinetic energy is equal to half of mv square. So half of m into 2gh. Right? Now at this case, 2 get cancelled. We get mgh as a kinetic energy. What about potential energy? Now body is at ground. So potential energy becomes 0 as h is 0. Because potential energy होता है mgh और h is 0 होता है तो potential energy होता है 0. So what will be the total energy? Total energy is kinetic plus potential energy. Kinetic I got mgh, potential I got 0. So it is mgh again. So at these three different positions we found the energy possessed by the body, and at every stage at the position A we find that total energy is mgh, at B we found total energy is mgh, and at C again we find total energy as mgh. Means whenever the potential energy get converted into the kinetic energy form, then we find that for a free fall body, the total total energy possessed by the body, which is nothing but a sum of potential and the kinetic energy, and it is always constant. Here we find mgh at all three different positions. Any doubt? I hope that you are all of this you understood. Application based question may be asked on this topic. Right? Now let's see another topic. Similarly, here in your book, energy profile diagram is shown, right? Energy profile diagram. Let's see that energy profile diagram in your book. Here, at the x-axis, height above the ground of the body is taken, right? And at the y-axis, energy is taken, right? Now the graph is drawn for the kinetic energy and the potential energy. So this graph shows when the body is at height 0, okay, when body is at height 0, then the potential energy starts increasing when it goes up, right? Okay, and the kinetic energy at this point decreases, right? So this shows kinetic energy graph and this shows potential energy graph, right? This you keep in mind. Second thing, at the initial stage, here this is nothing but the coordinate, meeting point of coordinate axis. So the origin, so value is 0, right? Now here you can see that as the height starts increasing, the potential energy also increases, because potential energy possessed by the body is due to the height gained by the body. So here जैसे हाइट बढ़ती जाएगी, यहाँ पर देखो जैसे हाइट बढ़ती जाएगी, ये वैल्यू पे कुछ हाइट थी, ये वैल्यू पे कुछ हाइट थी, यहाँ पर एक कुछ हाइट है, ओके, हर एक जगह पे कुछ ना कुछ हाइट है. जैसे हाइट बढ़ती जाएगी वैसे पोटेंशियल एनर्जी बढ़ती जाएगी. मीन्स पोटेंशियल एनर्जी इंक्रीजेस एज हाइट इंक्रीजेस. तो आपको ध्यान में आ जाएगा, राइट? सेकेंड थिंग, as the height increases, kinetic energy you find decreases. Kinetic energy decreases and height increases. So what I said, height when 0, then kinetic energy is max over here. So I can say maximum kinetic energy over here. And when height is h, means 0 नहीं रहेगी, but वो कुछ ना कुछ हाइट पे गया है, तो यहाँ पर जैसे पूरे हाइट पे वो चला जाएगा, तो यहाँ पर हो जाएगा काइनेटिक एनर्जी 0, राइट? What about potential energy? When the height is 0, then the potential energy over here is 0. But as the height becomes h, then the potential energy over here is max. Over here we find the potential energy maximum, right? So this energy profile diagram suggests us like this. If I say this point is h by 2 height. कितनी height है? h by 2. So what we find at this position m, I find that half of kinetic energy plus half of potential energy, and together gives us a total kinetic energy over here at this point m, right? So वहां पर हम ये पता चलता है. Okay, next means half of kinetic mgh, half of mgh gives us total energy. That is nothing but half of mgh plus half of mgh and gives us mgh. Okay, at this point m. Next is application of principle of conservation of energy, and one of the application of this principle of conservation of energy is simple pendulum. Let's see. See that a bob is suspended by a massless and inextensible string toward Z support, and when we take this bob toward extreme position, okay, and if we leave it, okay, what we find? If we leave it, then we find the bob starts oscillating. Bob क्या करेगा? Start oscillating. वो oscillate करना शुरू कर देगा. Now, if I take the three different positions over here for the pendulum, then here actually it is center of the bob. Huh? Actually it is center of the bob. Center में ही समझना है हमें यहाँ पर. Here the height is 0, right? And over here you can see that the height is h. H height पे bob यहाँ पर है. Say position A, position B, and say position C. Whenever the bob is at a height A, then here we find that when it goes up to the last point, then here we find that due to the height it possesses potential energy mgh. At that position, no movement, so kinetic energy becomes 0. Okay? At the position B, when it reaches to h, then here h becomes 0. H0 means what? Which implies potential energy is 0. Potential is 0, so it gets converted totally into kinetic energy as mgh over here at the position B. And at the position C, due to the gain in height, okay, potential energy become mgh, okay, and kinetic energy becomes 0. So I can say over here the total energy get conserved. Here mgh plus 0 is mgh at position A. When it reaches to position B, h becomes 0, so potential energy is 0 and kinetic is mgh. So here we find again mgh, total energy, and at C, potential energy is due to the height, that is mgh, and kinetic energy becomes 0. So over here again, total energy becomes mgh. Means at these three different positions we find the total energy is constant. So this is nothing but the verification as well as the application of energy conservation principle. What is that? Energy neither be created nor be destroyed, only it transfer from one state to another state. एक स्टेट से दूसरे स्टेट में कन्वर्ट होती है, बाकी उसका कुछ होता नहीं है. That's why I put a statement that total energy possessed by the body is nothing but sum of potential and kinetic energy. If potential energy get converted only into the kinetic energy, right? Means total sum of all the energies in this universe is constant. So this verification as well as the applications are given in your ICSC. So those are completed. This chapter is over. Okay, we are going to keep our live session. Okay, and that time if more doubts you have, so you find those doubts and we will discuss. Okay, thank you.